Hey there, space enthusiasts. Today we've got something super exciting to talk about. NASA is considering sending an interstellar probe to study the heliosphere, the vast region of space influenced by the sun. Buckle up, because this is going to be a thrilling ride. The sun does more than just warm the Earth and make it habitable. Its influence extends way beyond our planet, creating a massive bubble around the solar system called the heliosphere. This region is hundreds of times larger than the distance from the sun to the Earth. The sun constantly emits a stream of highly energized ionized gas called plasma, known as the solar wind. On top of that, it occasionally releases huge eruptions of plasma called coronal mass ejections and bursts of light and energy known as solar flares. This plasma, along with the sun's magnetic field, spreads out into space, forming the heliosphere. Scientists, like heliophysicists, are keen to understand the heliosphere and how it interacts with the interstellar medium, which is the stuff, plasma, neutral particles, and dust filling the space between stars. Our entire solar system, including the 8 known planets, the asteroid belt between Mars and Jupiter, and the Kuiper belt beyond Neptune, is all within the heliosphere. Interestingly, the objects in the Kuiper belt are closer to the sun than they are to the farthest edge of the heliosphere. The heliosphere's protective shield. When distant stars explode, they send out cosmic rays, which are highly energized particles. These cosmic rays can be harmful to living organisms and can damage electronic devices and spacecraft. Earth's atmosphere protects us from these cosmic rays, but the heliosphere itself acts as a first line of defense, shielding us from most of the interstellar radiation. Besides cosmic rays, neutral particles and dust from the interstellar medium flow into the heliosphere. These particles can affect the space around Earth and may even influence how the solar wind reaches us. The mysterious shape of the heliosphere. However, scientists are still unsure about the exact shape of the heliosphere. Models suggest it could be spherical, comet-like, or even croissant-shaped. The direction the sun moves is called the nose direction, and the opposite side is the tail direction. The shortest distance to the edge of the heliosphere, or the heliopause, is in the nose direction. No probe has ever thoroughly examined the heliosphere from the outside or sampled the local interstellar medium. Doing so could reveal a lot about the heliosphere's shape and its interaction with the interstellar environment. Crossing the heliopause with Voyager. Back in 1977, NASA launched the Voyager mission. These 2 spacecraft traveled past Jupiter, Saturn, Uranus, and Neptune. Scientists believe that both Voyager 1 and 2 crossed the heliopause into interstellar space in 2012 and 2018, respectively. Although these Voyagers have gone beyond the heliopause, they were originally designed to study planets, not the interstellar medium. Their instruments are now failing or shutting down, meaning they can't provide the detailed data we need. This is where a new interstellar probe could make a huge difference. A probe designed to travel beyond the heliopause would help scientists understand the heliosphere by observing it from the outside. The interstellar probe. Given the enormous size of the heliosphere, it would take a probe decades to reach its boundary, even with a gravity assist from a massive planet like Jupiter. The Voyager spacecraft won't be able to send data from interstellar space by the time an interstellar probe exits the heliosphere. Once launched, depending on its trajectory, it could take about 50 years to reach the interstellar medium. So, the sooner NASA launches this probe, the better. NASA has asked over 1,000 scientists for their input on this mission concept. The initial report suggests the probe should travel on a trajectory about 45 degrees away from the heliosphere's nose direction. This path would retrace part of Voyager's journey and explore some new regions. This trajectory would give the probe a partial side view of the heliosphere, though it wouldn't cover the heliotail, the area we know the least about. In the heliotail, the heliosphere's plasma mixes with the interstellar medium's plasma through a process called magnetic reconnection. This process lets charged particles flow from the interstellar medium into the heliosphere, affecting the space environment within. A new perspective. In a recent study, my colleagues and I evaluated 6 potential launch directions ranging from the nose to the tail. We found that a trajectory intersecting the heliosphere's flank toward the tail would provide the best perspective on its shape. This path would allow scientists to study a new region within the heliosphere, and once the probe exits into interstellar space, give us a more detailed view of its shape, especially in the tail region. In the end, no matter which direction the interstellar probe takes, the science it will bring back will be invaluable and, quite literally, astronomical. Thanks for watching. If you enjoyed this video and want to see more exciting space content, don't forget to like, subscribe, and hit that notification bell. See you next time, Space Explorers. See.